And welcome to our bonus features section. We're going to show you some additional imagery here of the closest star, as well as what's going on in the bridge between Earth and space. Let's do it. Starting out with charging hazards, and we see quite a lot of charging hazards here. Some internal charging over the southern hemisphere and some surface charging from less energetic electrons in the northern hemisphere there over the central Pacific Ocean. Higher energy electrons causing the internal charging here in the southern hemisphere. Here's the one-year chart of the electron flux from solon.info. Here's a 3-day chart, and we just saw a drastic rise and drop there in the measurements from the GOES 17. These measure the electrons at the F ionosphere layer using radiography from their geosynchronous near equatorial orbits. So here's the forecast model from NOAA. NOAA was expecting a dip here in the electron flux. We didn't really see it. The coronal hole wind stream that was forecasted to cause some geomagnetic unrest never really arrived. And let's take a look at the total electron content. Here's your total electron content forecast showing you the most likely places on planet Earth for GPS errors. Shout out to Tamitha Scove. Hit me back on Twitter DMs so we can set up a video. Tamitha did a great video about the ionosphere, a 4-hour mini class doing a deep dive into the inner workings of the ionosphere, which way do the electrons flow, and so forth. Tamitha Scove, a great channel about that kind of stuff. Anyway, not a lot of chaos here. Anyway, that shows you where GPS errors are most likely to be located. Next, we're going to show you the F ionosphere layer in vibrational frequency and the anomalygram. So here's the vibrational frequency in megahertz. One slice of the atmosphere located at about 300 kilometers of altitude, the F ionosphere layer. We do see some significant low-frequency anomalies showing up here. And once that plays through, we'll show you the latest image after we show you the anomalygram. So here's the anomalygram, anomaly in megahertz from the 30-day median. Lots of low-frequency anomalies south of the equator. Some sudden swings there over Central Africa and South America once again. We'll go back to the ionogram to show the latest image. There it is, 12:30 Universal Time, and you'll see low-frequency anomalies here. There you go, 12:30 Universal Time for the anomalygram. Thanks to the Smash team, the true source of funding for the content, we replaced Patreon with a superior subscription services site. Consider becoming a member of the Smash team if you enjoy the content and wish to see it continue to exist. As you may know, we're paid just this side of nothing to put the videos on YouTube. I'm not sure if it's because of the pathetic censorship of the algorithms or what the deal is, but for some reason, algorithms seem a bit unfriendly to the channel. So consider becoming a member of the Smash team. Also, don't forget to press like and subscribe and so on. Next, we're going to show you the latest imagery here from the El Teide ground-based solar observatory. Give that a minute to load up. And there we go. Quite a few filaments here around the Earth-facing portion of the sun. Low sunspot activity, low radio flux. We're expecting a sudden uptick once again. Next, the latest intensitygram and latest colorized magnetogram as we show daily. As this sunspot sets, the only sunspot we're going to have is that one right there. It certainly looks like it. And there's a colorized magnetogram. Actually, magnetic organization has been dropping since yesterday and even since we did show prep. We'll close out with some more solar imagery here. This is the GOES 16 SUVI. I would note a bunch of crown prominences up here around the North Polar region. Coronal holes are the story. Make sure you watch our previous videos. We did one with a little bit of additional information about coronal holes. And we'll close out today's daily space weather bonus features with 171 angstroms, my favorite wavelength from the SDO. It's part of the ultraviolet spectrum, and it's associated with ionized iron. 8 times ionized iron, known as iron 9. Thanks for tuning in. And may that solar wind be at your back. opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name and News.